oh, it's so good, I want one. But they got problems. There's no camera. I can't take a picture of it, draw on that picture, you know, take a picture of this plant and then draw that plant with it, because I need a plant here in ones and zero lands. I don't care how I get it. I don't need to be able to craft it with a ZBrush or do anything else when I have this. This is a good tablet. Good tablet. But if you do too many things to it, it eventually becomes an iPad or a S7. Yeah, I mean, the screen, we're going to steal that, Tim. We're taking that thing. That's coming with us. Again, I like in itself, the purity. If you could open that app within the platform, that would be fantastic on the Apple. Get an app running for this thing, just the hardware behind it, and put it in a S7 or a iPhone. That would be amazing. And then maybe, again, if they got any tricks for the housing that Tim can't put in it already. I mean, obviously, like, well, let's change out that department, upgrade the idle mine here. I mean, boy, she's pretty. Anyways,
take notes, read, and review documents with unparalleled paper feel. Order your.
Somehow, the ones and zeros
hey there guys,
do this.
Paul here from the engineeringmindset.com.
Induction.
In this video, we're going to be looking at inductors to learn how they work, where we use them, and why they're important. Remember, electricity is dangerous and can be fatal. You should be qualified and competent
all the inductors on the table that was that diode right there.
So what is an inductor?
One's a capacitor, one's
an inductor
a T,
is
whatever.
A component
you gotta
in
pick
an electrical circuit which stores energy in its magnetic field. It can release this energy almost instantly, and we'll see how it does that later on in this video.
Major starts talking
Being
about
able to store and quickly release energy is a very important feature, and that's why we're going to use these in all sorts of circuits. Now, in our previous video, we looked at how capacitors work. Do check that out if you haven't already, links down below.
NP. This is
so
silica
how
with
does an
potassium
inductor
in it,
work?
and this is either silica with no potassium in it at the same purity state,
flowing through some pipes.
or some other fancy magic
there is
that they
a
put
pump
in
which
there.
pushes this water, and the pump is equivalent to a
General
battery in the circuit. The pipe will split into two branches, and the pipes are equivalent to our wires.
B1,
One branch
P2,
is a pipe
A1,
with a
A2,
reducer in it,
photon,
and that
gluon,
reduction
boson,
makes it a
boson.
little harder for water to flow
Is,
through it.
well,
So
gravity.
the
Well, sorry,
equivalent
you do
to
strong force,
resistance
weak
in our
force, or weak
electrical
force, strong
circuit.
force? We going left to right,
The
right
other
to left,
branch
up
has
to
a
down.
water wheel built into it. The water wheel can rotate, and the water flowing through it will cause it to
Now that we
rotate.
know that, the mods, we're on it.
The wheel is very heavy though, so it takes some time to get it up to speed, and the water has to keep pushing against this to get it to move. This water wheel is going to be equivalent to our
You feeling rich
inductor.
right now, kid?
When we first start the pump, the water is going to flow, and it wants to get back to the pump as this is a closed
See, we're
loop.
not going high orders.
This is just like when
get
electrons
hotter,
leave the
right,
battery, they flow and try and get back to the other side of the battery. By the way, in these animations, I use electron flow, which is from negative to positive. But you might be used to seeing conventional flow, which is from positive to negative. Just be aware of the two and which one we're using. So as the water flows, it reaches the branches and has to now decide which path to take.
Well,
The
in
water
induction
pushes against the
Tensor,
wheel,
we'd
but
say
the wheel is going to take some
the two
time to
batteries
get
there
moving.
have different
So it's adding
voltage.
a
They're
lot
both
of
9 volt, but
resistance
this one's 8.
to the pipe, making it too difficult
9
for the
or
water
8
to flow
point
through
whatever.
this path.
Its lifespans are
Therefore,
different.
the water will instead take the
thermodynamics
path of the
of
reducer
perfectly
because it
dynamic
can flow
machine,
straight
as
through
long
this
as
and
it
get back
stays
to the pump
with those
much
things
easier.
at the 0-1.
As the water keeps pushing,
behave.
the wheel will begin to turn
these
faster
are
and
also one of
faster
these.
until it reaches its
Except
maximum
for this one's
speed.
going this way using energy, and this
Now
one's
the
making
wheel
it.
doesn't provide almost any resistance, so
Or,
the water
yeah,
can flow
this gear
through this
into this
path much
gear,
easier
turn
than
the
the path with
our
the reducer in
transmission
it.
worm gear, right?
The
It's
water
turning
will
it
pretty
into
much stop flowing through
angular,
the reducer,
well,
and it will all now flow
angular
through the water
into
wheel.
rotational,
When we turn
back
off the
into
pump,
angular to
no more
turn the
water
drill
will
bit.
enter the system.
Whether it's
But
water,
the water
energy,
wheel is going so fast it can't just
But
stop. It
they're-
has inertia. As
it's
it
hard to
keeps
stop. You know,
rotating,
they're
it
the
will
ones
now
and
push
zeros
the
are always
water
on in
and
the
acts
river,
like a
so
pump.
you would hook it up to energy,
The
not a
water
drill.
will
You
flow
know.
around the loop
One
back
of these
on
to be
itself until the
capacitor
resistance
battery
in
in
the
the form of a
pipes and the
drill, ready to
reducer
be a
slows
drill.
the water down enough that the
Positive
wheel
attitude.
stops spinning. We can therefore turn the pump on and off, and the water wheel will keep the water moving for a short duration during these interruptions. We get a very similar scenario when we connect an inductor in
the
parallel
note
with
was
a
turning
resistive
copper
load such as a lamp.
Into a couple of
This
ingots
is the
by
same circuit as
radiation.
we just saw, but I've just
hot
wired it more neatly.
white steel induction
When we power the circuit, the electrons are going to first flow through the lamp and power it. Very little current will flow through the inductor because of its resistance at first is too large.
Your battery, Neo.
The resistance will reduce and allow more current to flow. Eventually, the inductor provides nearly no resistance, so the electrons will prefer to take this path back to the power source rather than through the lamp.
Computers
so the
and
lamp
general
will turn
zeros
off.
and wonder inductors.
When we disconnect the power supply, the inductor is going to continue pushing electrons around in a loop and through the lamp until the resistance dissipates the energy. So what's happening in the inductor for it to act like this?
Mukow into calories.
Well, when we pass electrical current through a wire, the wire will generate a magnetic field around it. We can actually see this magnetic field by placing compasses around the wire. When we pass a current through the wire, the compasses will move and align with the magnetic field. When we reverse the direction of the current, the magnetic field reverses, and so the compasses will also reverse direction to align with this. The more current we pass through the wire, the larger the magnetic field becomes.
The reason we still hear about is a cup.
When we wrap the wire into a coil, each wire again produces a magnetic field, but now it will all merge together and form one large, more powerful magnetic field. We can see the magnetic field of a magnet just by sprinkling some iron filings over the magnet, which will reveal the magnetic flux lines. When the electricity supply is off, no magnetic field exists. But when we connect the power supply, current will begin to flow through the coil, so a magnetic field will begin to form, increase in size up to its maximum.
I'm smart or read the bottles, just
the magnetic field is storing energy.
In the gas chamber.
When the power is cut, the magnetic field will begin to collapse, and so the magnetic field will be converted into electrical energy, and this pushes the electrons along. In reality, it's going to happen incredibly fast. I've just slowed these animations down to make it easier to see and understand.
3D helps you visualize your end product. By viewing your designs in interactive 3D, you can easily change the camera view to get a different perspective. And if your board has any flex regions, you can easily bend.
So why does it do this? Well, inductors don't like changing current. They want everything to remain the same. When the current increases, they try to stop it with an opposing force. When the current decreases, they try to stop it by pushing electrons out to try and keep it the way it was. So when the circuit goes from off to on, there will be a change in current. It has increased. The inductor is going to try to stop this, and so it creates an opposing force, and there's a back EMF, or an electromotive force. This back EMF opposes the force which created it. In this case, that's the current flowing through the inductor from the battery. Some current is still going to flow through though, and as it does, it generates a magnetic field which will gradually increase. As it increases, more and more current will flow through the inductor,
so the value of
and
that
the back
stock
EMF
market
will eventually fade away.
Like
the magnetic field will reach its maximum,
Apples
and the current
will have that dark matter in it.
The inductor no longer resists the flow of current and acts like a normal piece of wire. This creates a very easy path for the electrons to flow back to the battery, much easier than flowing through the lamp. So the electrons will flow through the inductor, and the lamp will no longer shine.
Remember this thing? I was like harassment.
When we cut the power, the inductor realizes that there has been a reduction in current. It doesn't like this and tries to keep it constant. So it's going to push electrons out and try to stabilize it. This will power the